Good morning, class. So today we're going to be continuing our work with permutations and combinations. First, for the word problems, this is our first word problem of the day. 10 kids are playing charades. There are 15 different things they can act out. If each kid takes a turn, how many different orders of kids and actions are possible? You can take this video and pause it now and try to figure it out for yourself. And now I'm going to work through it. Alright, so first things first, we have to look at the order of kids. So since we're dealing with permutation, that order does matter. We have to take n factorial over n minus k factorial. For the order of kids, the bottom part of it isn't going to matter completely, so order of kids is going to turn out to 10 factorial over 10 minus 10 factorial, which is just going to go to 10 factorial. So for our next part, we have to look at actions possible. So possible actions, order of actions. This is going to take out 15 factorial over 15 minus 10. Because for the number of actions and then the number of kids playing. Factorial. Right, an exclamation point. There we go. So for this part, this is going to get broken down and simplified into 15 over 5 factorial, 15 minus 10. So since these two events are independent of one another, we're going to take 10 factorial and multiply it by 15 factorial over 5 factorial. Keep in mind that this is a perfectly good answer. If you'd like to take it with the calculator, you're going to get a gigantic number out of this. And remember that this is taking into account for the order of kids and the actions possible when order does matter. Next, we're going to be talking about ice cream. Everybody loves ice cream. So say that you're at an ice cream parlor, and there are a total of, one moment please. There are a total of 5 flavors to choose from of ice cream. 5 flavors. And 7 different toppings. If I only have 3 scoops and 2 toppings available, what are the total number of combinations I can make? So with repeats, we need to remember that since there are 3 possible options for the ice cream, that's going to be 5, 5, and 5. That's 5 and 5. That's going to be multiplied with the number of toppings, because toppings and ice cream are independent of one another. So that's going to come out to 7 and 7. And this can get simplified down to 5 cubed times 7 squared. And this is going to give us a total number of options with repeats allowed. So that would be like chocolate, 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 and sprinkle, sprinkles, or vanilla, 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 and caramel, caramel, for instance. So that was with repeats. Now looking at it without repeats, we need to take into account the number of flavors we have. And since we have 5 flavors, we're going to have 5 flavors, and we're going to be choosing three flavors. That's going to come out to a total of, if you'd like to take this time and try to solve it on yourself, do so now. So I'm going to continue solving this problem. This is going to come out to 5 factorial over 3 factorial, and then the difference between 5 and 3, 2 factorial. This gets simplified down to 20 over 2. Keep in mind that the 3's are going to cancel at the top and the bottom. We're just going to be left with 5 times 4 over 2 times 1. This gets broken down to 10. And this gives us unique ice cream. That says ice cream. Next, we're going to do toppings. Same thing goes as here. So we have 7 different toppings to choose from, and we're picking 2. Or we're choosing 2. This is going to get broken down to 7 factorial over 2 factorial, and then 5 factorial on the inside. Keep in mind, simplifying, this gets broken down, so the 5's are going to cancel up top and bottom. We're going to be left with 7 times 6 over 2 times 1. That's going to go to 42 over 2, which equals 21. This gives us unique topping combos. Unique toppings. And keep in mind that since the 2 events of ice cream and toppings are independent of one another, we're going to take 10 times 21 for ice cream and toppings for a grand total of 210, unique ice cream combinations.